Okay, the clock has started ticking, so I guess we are gonna start. Hello, I am Paweł Mikołajczyk. I work at Zendesk here in Krakow as a backend engineer. And today I am here to show you an open source library that we have created, and it makes our test of our backend services basically more robust. It gives us confidence on every deploy to production, making us effectively more productive. Okay, if you have any questions about what I'm going to say in a moment, do not hesitate to ask on Slido. Okay, what is this library about? It's basically a tool for writing test assertions on JSON outputs. The plan for this meeting is to firstly show you when you might use this library, when it might be useful for you, and then we will do some little live coding, showing the examples to show how to use this library and present its best features. Okay, so first thing, why you may need this library? In a situation as, firstly, your system exposes a JSON API, and you write tests on this JSON API. Simple as that. But why somebody would like to write such tests? I can mention 3 reasons for this. Firstly, the API level the API interface is the interface that is the least likely to change. It is the contract that you have agreed with your customers, with your external client or clients in your own company, for example, another team. And yeah, this is the contract, so it's you optimize for not changing this interface. So if the regression suite for your service is written on this level, it firmly ensures you that the service is still working as expected, even if you do some major refactoring in the code. You can do a big bang in the implementation details, while if the regression suite written on the API level is still green, you may be sure that the system is working as expected. Another reason could be the fact that such tests basically cover more code, gives more coverage. They also cover the object serialization, the output serialization. This would be important when you when you offer the some exact format of decimal values or some exact format of date time fields. You need to ensure in your test that the output looks like it was promised. Third reason is that such tests are great for driving your development through tests. The first thing that you have on the starting of the service is the API you have agreed with the external team or your front-end team in your company. And to start the development, you just write the test on the API level, write the code to satisfy the expectations on the API level, then test on API level, and so on and so on. To write this on the interface that is already agreed does not make you not diverge to unimportant things. Okay. Although I find this really great, I do not say that this is a silver bullet. And from now up until forever, you should start writing tests on API level and nothing more. Rather than a silver bullet, I find it a pretty reasonable default. Okay, so enough of talking. I will just switch to IntelliJ to show you what is this all about. Okay, we'll iterate through the list of features and show examples showing those features. One disclaimer, as you can see, this example is written in Spock framework. And this is mostly because we use Spock at work. And yeah, the library just emerged out of our tests, so it mostly supports Spock. But the library is written this way that you can, with low effort, write your own adapter to adapt it to your favorite testing framework. For example, in Scala, in Kotlin, anything. So every example we will see in Spock, but you can use it with other libraries. How the example looks like. This is a simple getting response out of some mocked client. And here we match this against an expectation. Simple as that. Let's execute it. OK, looks like it's working. Let's see some more complex example showing how does it display a mismatch error. OK, what you can see here, a much more big JSON. Sorry, and there's something wrong with my voice. OK, you can see that it's pretty complex with some type-safe envelopes. And here's the expectation for this JSON. You write it as a simple groovy map. Let's execute it. OK, it shows some mismatch. The mismatch says, gives the path to the item. Let's see it. Items, element number 0. Here is items. A list, element number 0. And data tags. Here's a list, and it says what? Array contains unexpected elements. Indeed, there is money here, while in the expectation, there is no. OK, so let's fix the code. Sorry. And execute again. Wow, it started passing. So you can see the errors are pretty human-readable, optimized for fast tracing of the mismatches. Another feature is that you often do not want to assert on the exact order of an inner array, but you are just interested that it contains some elements in whatever order. You do this with this library, with Jazon, passing here a set as an expectation instead of a list. Let's see it. OK, it shows that at tags here, there is a missing item, Dr. Pepper. Indeed, it is expected here at the second place. So let's add it at the last place and execute. You can see that it started passing while the order do not matter. Oops. Another important feature that I find most useful is that you can write any custom assertion. This is how this looks like. You have an object, and here's the expectation. The custom assertion is written as a groovy closure function, inline function, where for some technical field as ID or some technical field as updated timestamp, we just assert that one has some format bigger than 0 and the other just exists. It's not null. Let's see that it's working. Yes, it is. It's working fine. A good example for using such a wildcard assertion is to assert, for example, for a date time, that it has some certain format. So match it to a regex, which out of no reason I have here. Let's see it is working. Let's spoil it. And see that it discovered a mismatch on updated at field. Then the custom predicate doesn't match. Okay. The fifth feature is the fact that this library makes you stick to simple programming paradigms, simple programming principles, like do not repeat yourself. What you can do is just to extract those common wildcard assertions to some constants. Like this. And a date time. Okay. Here, this makes it much more readable. While it still catches the blah blah. All right. Optimize to minimize code duplication. You can go with this even further. Coming back to this test case, you can extract this whole object as a domain object, here called a deal, for which you will pass only the important fields, which is here the name, Coca-Cola, the value, this value, and jump to this. Return just a map. Here provide a map of defaults, the non-important fields, and return the defaults overridden with past keyword arguments, the important fields. So effectively, the test may look like this. It still passes. It's still testing and looks much more readable. All right. This is enough of coding. That's all of I wanted to show you in code. I already mentioned that it is extensible for any testing framework in any language, JVM language. Currently, as you can see, there is support for Spock. I also written a JUnit adapter. You can check it out, how to get it to your project on the GitHub page. Any feedback, any comments, issues, bugs, contributions are welcome. And from me, that's all. Thank you for your attention. And let's see some questions, if there are any. OK. Is there a simple way to externalize JSONs for assertion? I think I have shown that. That's answered. How much would this work? Would it require to return an adapter for Scala? So basically, I name it a lightweight adapter. It is sort of one class with one screen of code. There is an adapter for the unit and for Spock. You can look at it in the source code. OK, thank you. I think this is answered. And again, thank you for your attention.